Good. All right.
We're all good.
Let's get in trouble.
This concludes the earthquake drill. Thank you very much for participating and have a great rest of the day.
All right, we good? Okay. One. Okay, we're going to solve these systems of equations. That means there's more than one equation. Okay, so now you've been working on solving an equation and moving variables across equal signs and manipulating what they look like. Now you have multiple equations you're going to be dealing with. Okay, so one, you're going to solve one equation for one variable. All right, so there's a couple things we're learning in this section. This process that I'm showing you right now is called substitution. The next process I'll show you is called elimination. So whenever I say solve this system by substitution, you're going to follow this. So step 2 is substitute into the other equation. Okay, and when you do this, you're going to have probably parentheses and distribution you have to do just like you've been doing. So you'll have one big equation that you're working with, and you got to simplify it, just like what we've done in the last 2 sections. All right. So now you're going to solve that one equation that you've made for the one variable that there is. You'll have to combine like variables, like terms. You'll solve it, and that gives you one of the variables. Now, in both of these equations, you probably have 2 variables. You'll see what I'm saying in a minute as I give you the example. So we got to solve for the other variable that there is. So step 4 is substitute that substitute value into original equation. It's important to use the original to do this. And then 5 is solved. Okay, we good?
Yeah.
All right, let's see what that actually means. Example 1. Y equals negative 2x minus 1, and y equals 2x plus 3. All right, so here you have 2 equations. And you have 2 variables. Step 1, solve one of the equations for one variable, meaning get one equation to have one letter by itself. Do we already have that? Yeah, both of them are solved for one variable, aren't they? So step 1 is actually done. This has a variable by itself. This one has a variable by itself. Okay? And that's what you want to be a positive 1 coefficient. So both of these equations are solved for one variable. You only need one. All right, that's the key. Step 2 is substitute this information. I'm going to use the top equation. This is what y equals. So I'm going to take what y equals and substitute it for the y in the other equation. That's step 2. So I'm taking this information and putting it in the other equation for that y, because that's what y equals. Does everybody understand that I can do that? If I only knew what y was here, I could probably solve this equation. Wait, I do know what y is. Y is this. So I'm going to plug that in. So I'm substituting here. Negative 2x minus 1. Let's put parentheses around what we're substituting. We always put parentheses around anything that we substitute. And that equals the 2x plus 3. Now we have an equation like you did last week. Now, is there anything I need to distribute on this parentheses? Is there anything on the outside that I have to multiply by? And there's only a 1 out here, which means I don't need the parentheses at this point. So it's okay. Now, I need to get what? My variables on one side and my numbers on the other. So we're to our steps that we did last Friday. So how do I move this 2x to the opposite side? Yeah, subtract it. Not because that's a plus. Remember, that's a positive 2x, that's a positive 3. So those of you who struggle with this, this is how you move things. If you look at things like this, all you have to do is pick up that figure, put it on the opposite side, and give it its opposite sign. So that's a positive 2x. I'm going to put it over here as a negative 2x. And then it's gone on the right side. But then I have to put these two together. So what's a negative 2x and a negative 2x? Okay. So negative 4x. I still have a minus 1 on the left. And now I have a positive 3 on the right. Yes. Yeah. So again, if I want to move this whole thing, remember the operation is always attached to what follows it. If I want to move this to the other side, all I have to do is pick it up and move it and change the sign. Which is, if you really, the mathematical operation that you're doing is the opposite operation. But for those of you who struggle with this, anytime you move something to the opposite side of the equal sign, you got to change it to sign. Yes? So I add 1 to 4, or to 3 and we get 4. Okay, now what do I do? Divide both by negative 4. Because I want to get rid of whatever's attached to x. So x equals negative 1 in this situation. Okay, so from here down is what you did last week. Putting your variables on one side and solving the equation. That's what you did last week. This week you're learning how to substitute one equation into the other. Now we're not done. Step 4, substitute that value into one of the original equations. Okay? So this is what x equals. I'm just going to put it in the top one here. So y equals negative 2 times x. X is negative 1. Again, I'm putting parentheses around what I substitute. And then I also have to subtract 1 at that point. Now what's y equal? What's negative 2 times negative 1?
2.
Positive 2. And positive 2 minus 1 is? Negative 2 times negative 1 is positive 2, isn't it? Positive 2 minus 1 is 1. Alright. So again, but I want to explain what it is you actually found. Because right now it's just a bunch of letters to you, right? So you don't have to write down what I'm going to show you here if you don't want to. These are both in slope-intercept form, aren't they? Yes? Okay, so I'm going to graph them. You don't need to write this down, just watch, because I want to explain what it is you just found. Goes through the y-axis at negative 1. The slope is negative 2 over positive 1, right? So a negative 2 over positive 1 means I'm going to rise negative 2. That means I go down 2. And a positive 1, I'm going to run positive 1 to the right. That's the other point. I go down 2 more, go over 1 more. And keep doing it. Okay? So that makes a straight line. That's the graph of that equation. Let's do the other one. This goes through the y-axis at positive 3. Has a slope of 2 over 1. Up 2 and over 1. Up 2 and over 1. Up 2 and over 1. And you can keep going. It's not x and y value of where they meet means that they're on both lines, right? That point where they meet is on both lines, correct? Yes or no? Anybody not understand that? So if I pick this point here, this is the top one, y equals negative 2x minus 1. That point, whatever the x and y value is there, would work in this equation. The x value would go here, the y value would go there, and it would be a true statement. Any value on this line that I plug in for x and y will work, including the one right here. Okay? Any value on this line, this is the y equals 2x plus 3, I can plug in the x and y value, that coordinate in here, and it will be true. That y will equal whatever this expression is. Is everybody following me? And that includes this point right here. So if I pick this point, is that point going to be true in both equations? That's the solution to the system. It'd be neat if I could tell what x and y was on that coordinate. What you found was where those two lines cross. They cross at -1, +1. I was a little off on my graph. An accurate graph, it would be right on. The point is this. You just found a coordinate that will work in both of these. If y is +1 and x is -1, -2 times -1 is +2. +2 minus 1 is 1. All right. 2 times -1 is -2 plus a +3. +1. Any other point on those lines will not work in both equations. This is what you're doing. You're solving for the system of equations to find out what values will work in both equations. And you don't have to have just two. There could be 3, 4, 5 equations. But you're learning how to do 2. All right, so that's the purpose of learning this. Instead of just showing you, you now know what it is you're doing. Okay? All right, example 2. Y equals 5x minus 2, and the other equation is 6x plus 3y equals 15. Is step 1 done?
One of them.
Well, what's that say? What's step 1 say? Solve one equation for one variable. Is step 1 done?
Yeah.
Yes. This one's already solved for one variable. Okay? Step 2 is where you take that information. This is what y equals. And I'm going to plug it in for y in the other equation. Alright, so let's rewrite it. 6x plus 3 times whatever we're substituting. What are we substituting?
5x minus 2.
Here you go. 5x minus 2. This is where we start making you brilliant. At least you look like you're brilliant, right? Yes? Yeah, that's fine. I'm drawing it out for everybody.
Is this the
Okay?
same?
Yes. What do you mean the same thing? You do the same steps.
Because in the y and the minus edge, you get an edge, you
I had it in parentheses, but I didn't need the parentheses because there was nothing to multiply it by. That's why I said here there is.
Oh,
It's
yeah.
3 times y, right? Okay, so now what are you going to do? It's just, from here on down, it's just like last week, guys. What do I have to do first?
No, distribute.
Distribute.
Oh,
All right, so we have 6x plus 15x minus 6 equals 15. We good? Branson? We good? Okay. You're going to do this in Algebra 1 as well.
Oh.
But you'll have 4 equations, 5 equations. Okay? Algebra 2 you'll do more. But it's all a lot like this. I mean, it doesn't get much more difficult. Okay, so what do I do now?
Combine like terms.
Combine like terms. Well, there's There's a 6x, there's a plus 15x. They're on the same side of the equal sign, right? So I just add those together. Positive 6 and a positive 15 is? Okay, so that's 21x. I still have the minus 6 and the 15. Now what? Yep, move this to the other side. So 21x equals 15 and positive 6 is? Wait, got too fast. You guys catching up? 21. Wait, how do I get what?
How'd you split the minus 6 and 15?
Well, to move this across the equal sign, you do the opposite. You got to add 6.
Oh. Okay.
Whenever you go across the equal sign, it's the opposite sign. But what the steps are is once you get your variables on one side, everything else has to go to the opposite side. So that's why we moved the minus 1 by adding it to this side. That's how I got 4. So to remove the minus 1, it becomes positive 1 over here. Because the x's are over here, I got to get rid of that minus 1. I want to get x by itself. That's the whole goal. Yes, Effie.
Okay, so that's the answer you don't put.
Oh, I'm not done. What do you do now? I'm not done. I got to get x by itself.
Oh, you divided.
There you go. All right, so we divide off the 21, x equals 1. Okay, so that's, if you were to look at this on the graph, you know that the lines are going to cross somewhere where x equals 1, somewhere on that line. Okay, so you know what the x value is to your solution, which is 1 in this case. And this is how you're going to give me your answer today, your x and your y. This is the answer to that problem. Okay? All right, now what do I do? What? Yes?
Plug it into the y equals 5x.
Yeah. Pick one of the original equations that you think is going to be easier to solve. I would pick that top one. Y equals 5 times x, which is 1, minus 2. Yep, y equals 3. So your answer on your page tomorrow is going to be this. Write it like that, 1, 3. That's the coordinate where those two lines cross. Yeah.
Can you get more than one answer? Like more than one?
Now you can't have no solution, you can have infinitely many. But today, this is really what we can have. No solution would be you have two parallel lines that go across. Okay? Infinitely many is if you have one line and then another line on top of it. They cross at infinitely many points. Okay? So those are possibilities. Example 3. This is called elimination. X minus y equals 5. X minus 4 equals negative, x minus 4y equals negative 2. Alright, now we're not substituting. This is a new way of solving the system. Again, you're finding where the two lines cross. On these two examples, we substituted one equation into the other. This one, we're going to add the two equations together. So, the whole point in adding equations together is that when you add them together, one of the variables will be eliminated. It will go away. Let's say this was a negative 3x here. And I added these together. 5 plus negative 2 would be 3. Negative 1y minus 4y would be negative 5y. And 3x plus negative 3x would be what? 0. It would be gone. And you'd only have a y left and you could solve it. But the thing is, if I add either of these two together, the variable doesn't go away, does it? Okay, so now you get the freedom of changing these equations. Let's do what I said I want to do. I want to make this a negative 3x. I just can't make that a negative 3x without following our math rules that we've learned this year. If I multiply this by -3, what do I have to do to make it so that's okay to do? On both sides and to every term. Remember, back in chapter 2, I said if you multiply by something in an equation, if you introduce something into the equation through multiplication or division, you have to do it to every term. So that means I'm going to take this times a -3, that times a -3, that times a -3. Okay? So this becomes I'm going to rewrite it. Rewrite the whole thing. 3x minus y equals 5. And the new equation below it is going to be -3x. What do you think this is going to be? Yeah, this will be a positive. -3 times a -4. Yeah, it'll be positive 12y. And this becomes positive 6. Oh, it's -3. Okay, so watch what happens. The x's are eliminated, right?
No.
3 and -3 is 0.
Yeah.
So they are now gone. What do we have left? What's -1y and positive 12? 11. 11y.
Oh.
What's 5 and 6? No, we're not subtracting. We're adding. We're adding. So -1 and positive 12 gives me positive 11. 5 plus 6 is 11. Now what do I do? What do I get? So y is 1. Again, that's that value. I got to find x. Now you go back to what we're doing. Step 4. You're ready for step 4. You're going to substitute that back into one of the original equations. So that's called elimination. All right, so I plug this back in. I'm going to put it in the top one. 3x minus y equals 5. Everybody solve it. What am I going to do?
Needs to be plus 1
Yep.
on both sides. And 6 and then divide by 3.
Good. And that's where those two lines, if you graph them, would cross. They cross at 2, 1. That's elimination. Now listen, if you don't need to multiply by something, if something will eliminate itself just by adding the two equations together the way they are, then go ahead and add them together. You might have to multiply the bottom one by a number and the top one by a number to get one of the variables to eliminate. But what's the key? One has to be a positive, one has to be a negative if you're going to add. Okay? Example 4. X plus 1.5y equals 7.4. And 3x minus 0.5y equals -6.8. Man, that's ugly, isn't it? How about we just multiply everything by 10 to get rid of the decimals? Will that make you feel better? Alright, so we get 10x plus 15y, right? It moves it to the right one. Doesn't multiplying by 10 move the decimal to the right one then? 10 times everything. I'm going to multiply everything by 10 because this has a decimal place and so does that one. The highest decimal place there is just 1 in both equations. If this had 2, I'd multiply this one by 10 and this one by 100. To move in 2 places, okay? But they're all 1 decimal place, so I'm just going to multiply both equations by 10. Remember, you can do anything you want provided you follow the rules. So this equals 74. What's the bottom one equal? 30x minus 5y -68. Now if I add them together like this, does anything get eliminated? No. So what do you want to do?
I had times the 5 by
0.5 times 10 is 5. Here's what you can do. Watch. There's two problems. I can make this a negative 30x by multiplying by negative 3 all the way through. Or I can make this a negative 15 by multiplying by what? Positive 3. But I'd have to multiply everything by positive 3. You get to choose. It doesn't matter. You're still going to get the same answer. But I don't want to make that 90. So I'm going to multiply this by negative 3. That's just an opinion. You can do this one if you want. What?
How many times can you times by?
As long as you follow the rules, as many as you want. Okay? So I'm going to multiply this by negative 3. Or do you guys want to get rid of the y? Alright, so let's just rewrite it. That's negative 30x on the top, a negative 45y on for the y, and then 210 and 12 is 222, negative 222.
2 is 45.
3 times 15 is 45. Alright, and the bottom stays the same because it gave us our eliminated variable. Now I'm going to add those together. What happens?
30x.
Yeah, the x's are gone. They're eliminated. Now what do I get? Negative 45 plus a negative 5.
Negative 50.
Negative 50. Negative 222 and negative 68. Negative 290, those of you who love to add. Divided by negative 50. And you get a decimal, y equals, well, 5 4/5 is what that comes down to. It's positive. Why is it positive? Negative over negative. Okay, and the decimal, that's 5.8. I'm not going to go ahead and put it back in because of time, but you already know what to do with it. You substitute it back in and you figure it out. All right, your assignment. Page 320. 2 to 34 evens. That's 17 problems, guys. All right.